refractive index of a material of each optical element shown in the following diagram is less than its surrounding medium. Which of the correct ray diagram? We know that if the refractive index of outer medium is less than refractive index of a lens, it is acting as an opposite lens. It means if the lens is a convex lens, it should be act as a concave lens at the denser medium. Therefore, answer should be 5. There is a convex lens, it should act as a concave lens because of outer medium is a denser medium. Power of lens combination is 44 diopters. The power of one of lens is 40 diopters. The magnitude of focal length of other lens. We know that according to lens combination equation, 1 over f equals 1 over f1 plus 1 over f2. 1 over f means power. Power of this lens is 40. Then power of this lens should be 4 to get the power of combination as 44. Then we have to find frequency related to this power. 1 over f2 equals 4. f2 equals 1 over 4. 0.25 meters. We can get power in SI unit, diopters, by using meters as a focal length in meters. Therefore, it should be 0.25 meters. It means 25 centimeters. Answer is 4. Two monochromatic light rays and light rays A and B, after passing through an optical element P, emerge as shown in the figure. The optical element is. It should be like this. We can get it by using a prism with corresponding angle. Then it should be a prism. Answer is 5. A convex lens of focal length 25 centimeters is kept in a contact with concave lens of focal length 10. The power of lens combination in diopters. Then we can get 1 over f equals 1 over f1 plus 1 over f2. Focal length of convex lens is 25. It means minus 25. We have to substitute focal length in meters. Therefore, we have to divide it by 100. Focal length divided by 100. 1 over f value means 100 divided by focal length. Plus, the second lens is a concave lens. Its focal length is a plus value. 1 over 10, we have to convert it to meters. Then we can simplify it. LCM 50, 50 divided by 25 to 200 minus 50 divided by 100 plus 50 divided by 100, 10, 5 into 100, 500. Then we can get plus 200, plus 300 divided by 50, 6 diopters. Then answer should be 2. Consider the following statements made about the magnification M of an image produced by a convex lens at object distance. Statement A. From u equals 0 to u equals f, M increases. We know that image distance and object distance of a convex lens should be like this. From 0 to f, it means this range, we can see that image distance is increasing from 0 to infinity. Therefore, A is correct. From U equals 0 to F, M is increasing and moving from 0 to infinity. Always image distance is greater than object distance. It means it is a magnified image. Then B, from F to 2F, M decreases. F to 2F, we know that this point is 2F point. F to 2F, object distance is this value, image distance is this value. We can observe that image distance is decreasing. There is a curve like this. Therefore, magnification means image distance divided by object distance. It is decreasing. We also correct. From U equals to F to infinity, M increases. 2F to infinity means this part. No, image distance is decreasing. Therefore, we know that ratio between image distance and object distance is the magnification. It is decreasing. Then answer is only A and B are true. Third one is the correct answer. 20. Which of the following optical elements could turn a ray of light as shown below? We can get given rays by using a prism. Then A is correct. B is concave lens. We can't get by using concave lens. For any ray, we know that concave lens is moving rays from this main axis. Then B is incorrect. C is correct. We can get convex lenses to get given rays. Then A and C only. Answer should be 4. When an object is placed 10 centimeters from the lens, its image is formed 10 centimeters behind the object. The focal length and type of lens respectively are. When object is placed 10 centimeters from the lens, then object distance 10. Its image is formed 10 centimeters behind the object. It means image distance should be 20. Then we can use lens formula. 1 over V minus 1 over U equals 1 over F. Image distance is 20. It is a plus value. Object distance 10 is also a plus value. We have to find F. SCM 20 divided by 21 minus 20 divided by 10, 2. 1 over F. Then we can get F equals minus 20 centimeters. Minus means convex lens. Focal length 20. Then answer should be 5. Question number 20. A thin glass, refractive index 1.5, lens is immersed in water, refractive index 1.33. Which of the following ray diagram is wrong? Refractive index of outer medium is less than refractive index of lens. Therefore, we can consider that the lens is placed in a rare medium. In a rare medium, lens type is not changing. Therefore, rays should move away from the main axis. Second one is incorrect. In second answer, the ray is moving towards the main axis. Then answer is 2. A broad beam of parallel light is to be converted to narrow beam of parallel light. This can be achieved with 2 convex lenses. We can use 2 convex lenses to convert a beam like this. We can use 2 convex lenses. We can convert this beam to a narrow beam. A is correct. B, we can't use concave lenses. B is incorrect. C, a convex lens and concave lens. Yes, we can use it. Convex lens and a concave lens like this. Lens should be placed at a point like this. Then we can observe 2 parallel rays. It means a narrow parallel beam. C is correct. A and C. Then answer is 4. A beam of a light appears to be converging to a point of the axis 10 centimeters behind the lens. Is actually converged to a point on the axis 8 centimeters behind it. The lens is a beam of light that appears to be converging to a point at 10 centimeters behind the lens. It is like this. We can consider that there is a virtual object at this place. It is 10 centimeters. But actually converges to a point 8 centimeters behind it. It means we can consider object distance should be 8. Then we can use lens formula. 1 over v minus 1 over u equals 1 over s. 1 over image distance is 8, object distance is 10. Both values are minus 1 over s. Then we can simplify. LCM 80. 80 divided by 8. 10. It is a minus value. Minus into minus plus 8. 1 over s. We can simplify it and we can get x should be minus 40. Minus means a convex lens, focal length 40. Then answer is 1. The image of an erect virtual object which is situated between the lens and its focus formed by a diverging lens is, they have given 5 answers. First one is real, erect and larger than the object. Diverging lens. We can consider VU curve for a diverging lens. Diverging lens means concave. We can get graph should be like this. This one is the focal length. Now object distance is less than focal length. For a diverging lens, we can always see a real image and larger than image, then first answer is correct.